there is a point of light in the night sky, far too faint for your eyes to ever see, in the direction of a constellation you may have looked at 1,000 times without knowing. Around that point of light, that distant star, there orbits a world, a real world, an actual planet, more than 100 light years away, so far that the light leaving it tonight will not reach the Earth until long after this night is forgotten. And in the air of that distant world, in its atmosphere, the most powerful telescope humanity has ever built may have detected something that, if it holds up, would be one of the most profound discoveries in the history of our species. It may have detected the faint chemical fingerprint of a molecule that here on Earth is made almost entirely by living things. Sit with the strangeness of that, the sheer improbable strangeness of it. Light left that distant star more than a century ago, long before any of us were born. A tiny fraction of that light grazed through the thin atmosphere of a planet circling the star, and in passing through that alien air, it was subtly altered, certain colors absorbed away by the molecules it encountered. That altered light then continued on its long journey across the dark, traveling for more than 100 years through the emptiness between the stars, until at last it reached a telescope drifting in space far from Earth, where it was gathered and spread out and studied. And in the pattern of colors missing from that ancient light, scientists believe they may have glimpsed the signature of a molecule that, on our world, is the chemical breath of life. A message, of a kind, written in starlight more than a century ago, carrying the faintest possible hint that the distant world it passed through might be alive. It is the kind of thing that when you truly let it land, can make the hair on your arms stand up. Not because it is frightening in any immediate way, but because it touches something vast and deep. The sudden, vertiginous sense of the true scale of things, of the distances involved, of the possibility that we are not the only living things in all that immensity. We go about our days inside the small, warm world of human concerns, and it is easy to forget the staggering context in which those days unfold. The vast, dark cosmos stretching out in every direction, filled with countless worlds, any one of which might harbor life. A hint like this one reaches in and reminds us abruptly of that larger reality, and the reminder carries a charge of awe so strong it can feel almost like fear, the feeling of standing at the edge of something far larger than ourselves. Let that settle for a moment, slowly, because it is the kind of sentence that is easy to read and almost impossible to truly absorb. A telescope, floating in space, looked at a planet so far away that we will never visit it, never photograph its surface, never know it as anything more than a faint shadow crossing a distant star. And by analyzing the thin sliver of starlight that filtered through that planet's air, it found a trace of a chemical that, in the only example of life we know, our own world, is produced overwhelmingly by living organisms, by the vast invisible multitudes of life in Earth's oceans. The possibility hanging in the air, tentative and unconfirmed and hotly debated, but real enough to make serious scientists catch their breath, is that we may have caught, across the unimaginable gulf of space, a chemical hint that we are not alone. Now I have to be careful and honest with you from the very start, because this is a story that demands honesty, and because the truth is, in its own way, even more gripping than the hype. This is not a confirmed discovery. No one has found aliens. No one has proven that there is life on that distant world. The detection is tentative. The statistics are not yet strong enough to be certain. The debate among scientists is fierce, and there are other possible explanations that have nothing to do with life at all. The careful, responsible thing to say is that the most powerful telescope ever built may have caught a possible hint of a possible sign of life, and that we do not yet know whether it is real. And yet, even with every one of those cautions firmly in place, the possibility is staggering, because it touches the oldest and deepest question our species has ever asked, a question that has haunted us since the first human looked up at the stars. Are we alone? Tonight we are going to journey into one of the most profound and unsettling possibilities in all of modern science. The possibility that, for the first time, we may have glimpsed a chemical trace of life beyond the Earth. We are going to understand the almost magical feat that made this possible, the way a telescope can read the air of a planet across 100 light-years of empty space. We are going to travel, in our imagination, to that distant world and learn what kind of strange and alien place it might be. We are going to understand exactly what was found, the carbon-bearing molecules and the tantalizing, controversial trace of a chemical that on Earth means life. We are going to take seriously the powerful reasons for caution, the ways this could turn out to be nothing, because the doubt is as important as the hope. And we are going to sit with the sheer weight of the question itself, the eerie, vertiginous, wonderful, and slightly terrifying possibility that the universe is inhabited, that we are not the only living things in all the vast dark, that somewhere out there, around a distant star, something might be alive. I want you to feel, as we go, both halves of this story at once, because they are equally important and equally fascinating. There is the soaring possibility, the thrill of a discovery that could rewrite our understanding of life in the universe, the dizzying thought that we might have caught the first chemical whisper of an alien biosphere. And there is the sober reality, the genuine and serious doubt, the long list of reasons this could turn out to be nothing at all. The temptation when telling a story like this is to pick one half and run with it, to either trumpet the discovery as if it were certain, or dismiss it as if it were nothing. But the truth lives in the tension between the two, in holding the wonder and the caution together, and that tension is not a weakness of the story. It is the most honest and most interesting part of it. We are going to hold both, the hope and the doubt, all the way through. Because the real situation, the one the careful scientists actually inhabit, is far more gripping than any tidy certainty would be. It is the situation of standing at the very edge of one of the greatest possible discoveries, peering into the data, seeing something that might be the answer to the oldest question we have ever asked, and not yet knowing whether it is real. It is the situation of genuine, suspended, electrified uncertainty, the kind that comes only at the true frontiers of knowledge, where we have reached far enough to glimpse something extraordinary, but not yet far enough to be sure of it. That is where we are with K2-18b, and it is one of the most fascinating places a curious mind can stand, right at the threshold of knowing, looking through, into a possibility almost too large to hold. But to feel the full weight of what this telescope may have glimpsed, we first have to understand the question it speaks to, the question that gives the whole thing its power, the question that has sat in the human heart for as long as there have been humans to look up. Because the search for a chemical trace in the air of a distant planet is not really about chemistry. It is about the loneliest and most profound question we have ever asked. For all of human history, we have looked up at the night sky and wondered whether anyone is looking back. Every culture that ever existed has gazed at those countless points of light and asked, in one form or another, whether we are alone, whether the universe is empty but for us, or whether it teems with other living things, other minds, other worlds full of life? It is one of the most natural questions there is, and also one of the most haunting, because for almost the entirety of our existence, we have had absolutely no way to answer it. We could wonder, we could imagine, we could tell stories, but we could not know. The stars were too far, our tools too weak, the silence too complete. The question of whether we are alone in the universe hung over us, vast and unanswerable, one of the great mysteries that seemed destined to remain forever beyond our reach. Think of how this question has followed humanity through every age. The ancient philosophers debated whether there might be other worlds with other inhabitants, arguing back and forth with nothing but reason and imagination to guide them. Across the centuries, as our picture of the cosmos grew, so did the question, expanding along with our understanding of how vast the heavens truly are. When we learned that the points of light in the sky were other suns, distant stars like our own, the question deepened. If our sun has worlds, might not those other suns have worlds too? And might not some of those worlds be alive? But always, in every era, the question ran far ahead of our ability to answer it. We could reason, we could speculate, we could yearn, but we could not look closely enough, could not reach far enough, could not gather the evidence that would turn speculation into knowledge. The question was always there, and the answer was always out of reach. And it is a question that touches something deeper than mere curiosity, something that reaches into our sense of who and what we are. To ask whether we are alone is to ask about our place in the order of things, about whether life and mind are cosmic commonplaces or cosmic miracles, about whether the universe is the kind of place that fills itself with living things, or the kind that produces them only once, by some extraordinary accident, in one lonely corner. The answer, whichever it is, would tell us something profound about the nature of reality itself, about whether the cosmos tends toward life, or merely tolerates it as a rare exception. This is why the question has never let us go, why it sits so deep in the human imagination, surfacing in our myths, our art, our dreams, our science. It is not idle wondering. It is one of the ways we try to understand what kind of universe we live in and what it means to be alive within it. Consider the scale of the silence. Our galaxy alone contains hundreds of billions of stars, and we now know that most of them have planets, that worlds are common, that the galaxy is filled with billions upon billions of planets of every kind. And beyond our galaxy lie hundreds of billions of other galaxies, each with its own vast swarm of stars and worlds. The number of planets in the observable universe is so enormous that it defeats comprehension, a number with more zeros than we have words for. And in all of that, across all those countless worlds, we have known of life in exactly one place. Here. One planet, out of an almost infinite multitude, is the only place we have ever known to be alive. Either life is staggeringly rare, a near miracle that happened only on our small world, or the universe is teeming with it and we simply have not been able to see. And for all of history, we have had no way to tell which. The discovery of just how many planets there are has only sharpened this question in recent years. Not long ago, we did not know for certain that any planets existed beyond our own solar system. The worlds circling other stars were a reasonable guess, but an unconfirmed one. Then, over the past few decades, astronomers began detecting them. First a trickle, then a flood, until we now know of thousands of confirmed planets around other stars. And we understand that these are merely the nearest and easiest to find, the tiniest sample of an almost incomprehensible multitude. The galaxy, we now realize, is absolutely filled with planets. On average, every star has at least one, and many have several, which means there are hundreds of billions of planets in our galaxy alone. Worlds are not rare exceptions, but the ordinary furniture of the cosmos, scattered everywhere we look. Where we once imagined our solar system might be unusual, perhaps even unique, we now know that planets are among the most common things in the universe, that the act of forming worlds is something stars do routinely, almost as a matter of course. The galaxy is not a vast emptiness sprinkled with a few rare worlds. It is crowded with them, a teeming multitude of planets of every imaginable kind, far more numerous than even the most optimistic astronomers of earlier generations dared to hope. And among that vast multitude, a meaningful fraction lie in the habitable zones of their stars, at the right distance for liquid water to exist, in the temperature range we associate with the possibility of life. Even if only a small portion of all those planets are potentially habitable, the sheer number means there could be billions of worlds in our galaxy alone, where life might, in principle, take hold. This is what makes the silence so striking, and the question so urgent. It is not that habitable real estate is scarce. The universe appears to offer it in staggering abundance. The question is whether life actually arises on those countless suitable worlds, or whether something about the origin of life is so difficult, so improbable, that even with billions of opportunities, it happened only here. The abundance of worlds turns the question from an abstract musing into a concrete puzzle, with so many possible homes for life. Where is everyone? And is anyone there at all? This is what makes the question so heavy, so haunting. Both answers are almost unbearable in their implications. If we are truly alone, if life arose only here, in this one place, then we are a single fragile flame of awareness in an unimaginable darkness, the only eyes the universe has ever opened upon itself, precious beyond measure and utterly isolated. And if we are not alone, if the universe is full of life, then everything changes. Our whole sense of our place in things, our understanding of how common or rare or special we are, the very meaning of looking up at the stars. Either answer would be profound. And the not knowing, the centuries and millennia of not knowing, has been one of the defining conditions of being human, a question we could ask but never answer, suspended over us like the night sky itself. For most of history, the search for an answer was confined to imagination and longing. People populated the heavens with gods and spirits, with beings on the moon and the planets, with whatever their hopes and fears suggested. But none of it was knowledge. It was all guesswork, projection, story. The actual question, whether real living organisms exist on real other worlds, remained completely untouchable, beyond any possible investigation. We did not even know, for most of history, whether other planets existed at all beyond our own solar system. The idea that we might one day actually detect signs of life on a world circling another star would have seemed like pure fantasy, a dream forever out of reach, the kind of thing that could never move from wondering to knowing. And then, in the span of just a few decades, everything changed. We discovered that other stars do have planets, thousands and thousands of them, until we realized that planets are not rare at all, but ordinary, that nearly every star has its own worlds. We built telescopes of staggering power and precision, instruments capable of feats that would have seemed like magic to earlier generations, and we developed techniques so ingenious that they let us do something almost unbelievable, not just to detect distant planets, but to begin to study them, to learn their sizes and temperatures, and even, astonishingly, to analyze the very air that surrounds them. The gases of their atmospheres, across distances so vast that the planets themselves are utterly invisible. For the first time in the history of our species, the ancient question of whether we are alone began to move, ever so slightly, from the realm of imagination into the realm of investigation. And at the very frontier of that effort sits the most powerful telescope ever built. The instrument that may have caught, in the air of a distant world, the first faint hint of an answer. The James Webb Space Telescope is, by almost any measure, the most ambitious and powerful observatory humanity has ever placed in space. It is a machine of staggering sophistication, a great golden mirror unfolded in the cold and dark, a vast distance from the Earth, far beyond the Moon, positioned at a special point in space where it can stare out at the universe in profound stillness and cold, its instruments chilled to within a whisper of the lowest possible temperature, so that their own heat does not blind them. It was decades in the making, the work of thousands of people, an instrument so complex and so delicate that its successful unfolding in space was itself one of the great feats of engineering in human history, and it was built for one overarching purpose: to see the universe more deeply, more sharply, and more sensitively than any instrument before it. The scale of the achievement that Webb represents is worth dwelling on, because it is the reason any of this is possible at all. Its primary mirror is enormous, far larger than any telescope mirror ever flown in space before, so large that it could not fit inside any rocket in one piece, and had to be built in segments that folded up for launch and then unfolded with breathtaking precision once the telescope reached its distant outpost in space. Each of those mirror segments had to be aligned to a tolerance finer than a fraction of the width of a human hair, working together as a single flawless surface to gather and focus the faint light of the cosmos. The entire telescope had to be kept colder than almost anywhere in the natural solar system, shielded from the heat of the sun and the earth by a vast sunshield the size of a tennis court, so that its own warmth would not drown out the faint infrared signals it was built to detect. Every part of it pushed the limits of what human engineering could accomplish. And all of that effort, all of that ingenuity and expense and risk, was justified by what such a telescope could reveal: the faintest, most distant, most subtle features of the universe, things no previous instrument could detect. Webb was designed to peer at objects of extraordinary faintness, to gather light that had traveled across enormous distances, to tease out details that had always been beyond reach. It is a light bucket of unprecedented size and sensitivity, paired with instruments of exquisite refinement, and together they give it the power to detect signals so faint that earlier astronomers could only have dreamed of them. It is precisely this combination of light-gathering power and sensitivity that allows it to attempt the almost impossible task of reading the atmospheres of distant worlds, of detecting the tiny imprint that a planet's air leaves on the light of its star. Webb sees primarily in infrared light, a kind of light beyond the red end of what human eyes can perceive, and this turns out to be crucial, because infrared light carries information that visible light does not, and because it can reveal things that would otherwise remain hidden. With its enormous mirror gathering the faint light of distant objects, and its exquisitely sensitive instruments analyzing that light, Webb can detect objects almost unimaginably faint and far away. But for our story tonight, the most remarkable of all its abilities is not simply seeing distant things. It is something far more subtle and astonishing: the ability to analyze the chemical composition of the atmospheres of planets orbiting other stars, planets so distant and so faint that they cannot be seen directly at all. Stop and consider how extraordinary that is. We are talking about a planet more than 100 light years away. A world so far that if you tried to travel there at the speed of our fastest spacecraft, the journey would take longer than humans have existed. That planet is utterly invisible. It does not appear as even a single pixel in any image. It is lost entirely in the overwhelming glare of the star it orbits. And yet, Webb can determine what gases are present in that invisible planet's atmosphere, can identify specific molecules in its air, can tell us something about the chemistry of a world we cannot even see. It is one of the most astonishing capabilities in all of science, a feat that borders on the miraculous, and it rests on a technique of real ingenuity, a clever trick of light and timing that lets us read the air of distant worlds without ever seeing them at all. Pause for a moment on the sheer improbability of what is being claimed here, because familiarity can dull our sense of how astonishing it is. We are saying that a machine built by human hands, launched into space, can determine the chemical makeup of the atmosphere of a planet so distant that its light takes more than a century to reach us. A planet we cannot see, will never visit, and know only as a faint disturbance in the light of its star. There is no probe traveling there, no spacecraft sampling the air, no direct contact of any kind. There is only light, the faint light of a distant star, a tiny portion of which happened to pass through the planet's atmosphere on its long journey toward us, carrying within it the imprint of the gases it passed through. And from that faint, filtered light alone, we can deduce what that distant air is made of. It is a feat that would have seemed like pure sorcery to astronomers of earlier eras, and it remains, even to those who understand it, genuinely awe-inspiring. This is what science at its best can do. It can reach out across distances that defeat the imagination and extract real, specific knowledge about places we can never go. The atmosphere of K2-18b is not a matter of speculation or guesswork. It is something we can actually measure, actually analyze, actually learn about, despite its unimaginable remoteness. That such a thing is possible at all is a testament to centuries of accumulated understanding, to our hard-won knowledge of how light and matter interact, of how each molecule leaves its signature in the light that passes through it, of how to build instruments sensitive enough to read those signatures across the void. The detection of molecules in the air of K2-18b is not just a fact about that planet. It is a demonstration of how far the human capacity to know has extended, of how we have learned to read the universe itself, written in the language of light. To understand what Webb may have found on that distant planet, and to judge for ourselves how much weight to put on it, we need to understand this technique, because it is the foundation of the entire discovery. We need to understand how it is even possible to learn what a planet's atmosphere is made of from across more than 100 light years of empty space. And once you understand it, the achievement becomes even more breathtaking, and the tentative, controversial, tantalizing hint that Webb may have caught becomes even more gripping. So let us look at how a telescope reads the air of a world it cannot see. The technique relies on a simple and beautiful piece of luck in the geometry of distant solar systems. From our vantage point on Earth, some planets, as they orbit their stars, happen to pass directly between us and their star, crossing in front of it from our point of view, in an event astronomers call a transit. When a planet transits its star, it blocks a tiny fraction of the star's light, causing the star to dim very slightly, and by watching for these tiny, regular dips in brightness, astronomers can detect the presence of a planet they cannot see. This method of finding planets is remarkable enough on its own, and it is worth understanding how delicate it is. The dimming caused by a planet crossing its star is minuscule, often a fraction of a percent, a tiny shadow passing across an enormous brilliant face. To detect it requires measuring the brightness of a star with extraordinary precision, watching patiently for the slight, regular dip that betrays a planet passing in front, again and again, with each orbit. By timing these dips, astronomers can determine how long the planet takes to orbit its star, and from that, how far it sits from the star, and therefore whether it lies in the habitable zone. By measuring how much light the planet blocks, they can estimate its size. From these simple observations of starlight dimming, an astonishing amount can be learned about a world no one can see, its orbit, its size, its place in its solar system, all read from the faint rhythm of a star's flickering light. It was through exactly this kind of patient watching that K2-18b was first found, detected as a tiny, regular dimming of its star as the planet crossed in front of it over and over. From those dips, astronomers learned its size and its orbit, and realized that it sat in the habitable zone of its star, a world worth closer study. But knowing a planet's size and orbit is one thing. Learning what its atmosphere is made of is another, far more difficult thing, requiring not just the detection of the transit, but the careful analysis of the starlight that passes through the planet's air during that transit. And that is where the true power of a telescope like Webb comes in, and where the story moves from simply finding a distant world to actually reading its chemistry, to teasing out the faint fingerprints of the gases in its sky. But the real magic happens in the details of the light during that transit, because of what happens to the starlight that passes not in front of the planet, but just around its edge, grazing through the thin shell of its atmosphere. Picture the moment of transit. The planet is crossing in front of its star, and most of the star's light streams past on either side, unaffected, but a small portion of that light passes through the planet's atmosphere, the thin layer of gas surrounding the world, on its way to us. And here is the crucial point. As that light passes through the atmosphere, the gases in the air absorb certain specific colors, specific wavelengths of light, and let others pass. Every kind of molecule, every gas, absorbs its own particular set of wavelengths, a unique pattern like a fingerprint. Water vapor absorbs certain wavelengths, carbon dioxide absorbs others, methane others still. Each molecule leaves its own distinctive signature in the light, removing its own specific colors from the beam that passes through. So when that starlight, having grazed through the planet's atmosphere, finally reaches Webb's instruments, it carries within it a hidden message. By spreading the light out into its component wavelengths, like a prism spreading sunlight into a rainbow, and looking carefully at which specific wavelengths are missing, which colors have been absorbed away, astronomers can read off which molecules are present in the planet's air. The missing colors are the fingerprints of the gases that removed them. It is, in essence, a way of chemically analyzing the atmosphere of a planet from across the galaxy, using nothing but the light that happened to pass through that atmosphere. On its way to us, the planet itself remains invisible, lost in the star's glare, but its atmosphere writes its chemical signature into the starlight, and Webb can read it. It is hard to overstate just how delicate this measurement is, how close to the edge of the impossible. The amount of starlight that passes through the thin shell of a planet's atmosphere is a vanishingly small fraction of the star's total light, and the dimming caused by the absorption of specific molecules within that atmosphere is smaller still, a change in brightness so minute that detecting it is like trying to notice a single firefly dimming slightly in front of a distant searchlight. The planet is more than 100 light-years away. Its atmosphere is a thin film around a world we cannot see. And the signal we are after, the slight deepening of certain colors caused by particular gases, is a whisper buried in an ocean of starlight. To pull that whisper out of the noise requires not only an extraordinarily sensitive telescope, but also painstaking analysis, careful statistics, and repeated observations, because the signal is so faint that distinguishing it from random fluctuations is itself a formidable scientific challenge. This difficulty is not a minor technical detail. It is essential to understanding everything that follows, including why the results are so debated. When you are working at the very limit of what your instrument can detect, when the signal you seek is this faint, the line between a real detection and a statistical illusion becomes perilously thin. A pattern that looks like the fingerprint of a molecule might be genuine, or it might be a chance arrangement of noise that happens to resemble one. This is why claims about the atmospheres of distant worlds, and especially claims about possible signs of life, must be treated with such care, and why a single observation is rarely enough. The very faintness that makes the achievement so astonishing also makes it fragile, easy to misread, demanding of caution. We are reading the air of distant worlds, yes, an almost miraculous feat, but we are reading it through a glass darkly, straining to make out faint signals at the edge of perception. And that is the context in which the tantalizing hint from K2-18b must be understood. This is what makes the whole endeavor possible. And it is worth pausing to appreciate just how extraordinary it is. We cannot see the planet. We will never go there. And yet, by catching the faint light that filtered through its air during the brief moments of a transit, and by carefully analyzing which colors that air absorbed, we can determine what that distant, invisible world's atmosphere is made of. It is a feat of almost unbelievable subtlety, made possible only by the immense power and precision of a telescope like Webb, able to detect the minuscule changes in starlight that betray the presence of specific molecules in an atmosphere more than 100 light-years away. And it is this technique, applied to one particular distant world, that produced the tantalizing and controversial result at the heart of our story. So let us turn now to that world itself, the strange and distant planet where Webb may have caught its haunting hint. The planet is called K2-18b, a name that sounds more like a catalog entry than a world, because that is essentially what it is, a designation given to a planet discovered orbiting a star called K2-18. That star lies about 120 light-years from Earth, in the direction of the constellation Leo. It is not a star like our Sun. It is a red dwarf, a smaller, cooler, dimmer kind of star, the most common type of star in the galaxy. And around it, in an orbit far closer than the Earth's orbit around the Sun, swings the planet K2-18b, completing a full year in just a little over a month of our time. Because its star is so much cooler and dimmer than the Sun, this close orbit places the planet in what astronomers call the habitable zone, the region around a star where temperatures could, in principle, allow liquid water to exist. And liquid water, as far as we know, is one of the essential ingredients for life. It is worth pausing on the kind of star K2-18b orbits, because red dwarfs are both promising and problematic as hosts for life, and this matters for the whole story. Red dwarfs are the most numerous stars in the galaxy by far, vastly outnumbering stars like our Sun, which means that if life can arise around them, the universe has an enormous number of potential homes for it. They are also long-lived, burning their fuel slowly and steadily over spans of time far greater than the lifetime of a Sun-like star, which in principle gives life ample time to emerge and develop. For these reasons, planets around red dwarfs are among the most important targets in the search for life beyond Earth. But red dwarfs, have a darker side as well. Many of them are prone to violent outbursts, flares of intense radiation that could batter and strip the atmospheres of nearby planets. And because their habitable zones lie so close to the star, any worlds there are exposed to this fury. Whether life could survive such an environment is an open and much debated question, and it adds yet another layer of uncertainty to the prospects of any particular world, including K2-18b. The planet's close orbit, completing a year in little more than a month, also means it is likely locked in its rotation, always showing the same face to its star, the way our moon always shows the same face to Earth. If that is so, then one side of K2-18b would be in perpetual day, and the other in perpetual night, a world divided between eternal light and eternal darkness, with whatever ocean or atmosphere it has distributing heat between the two. It would be a strange place by the standards of Earth, with no familiar cycle of day and night, no rising or setting star, just a fixed sun hanging forever in one half of the sky, and an endless darkness in the other. Whether such a world could support life, and what that life might be like in such conditions, is yet another of the many unknowns that surround this distant planet. A reminder of how alien these other worlds truly are, how little they resemble the familiar Earth, and how much we still have to learn before we can judge their prospects for life. But K2-18b is not a second Earth. It is a very different kind of world, and a strange one. It is what astronomers call a sub-Neptune, a type of planet that has no counterpart in our own solar system. It is considerably larger than Earth, with a radius more than 2.5 times our own, and it is much more massive, weighing in at around 8 or 9 times the Earth's mass. This puts it in a peculiar middle category, bigger than the rocky worlds like Earth, but smaller than the great gas giants like Neptune. Sub-Neptunes turn out to be extremely common in the galaxy, perhaps the most common type of planet of all, and yet, because we have none in our own solar system, we understand them poorly, and we are still working out what they are actually like. K2-18b is one of these mysterious in-between worlds, and its true nature is the subject of intense debate. The mystery of sub-Neptunes is one of the genuine puzzles of modern planetary science, and it is worth understanding, because it sits at the heart of why K2-18b is so hard to interpret. In our own solar system, there is a clear gap. We have rocky worlds like Earth and Mars and Venus, and we have giant worlds like Jupiter and Saturn, and the somewhat smaller Neptune and Uranus, but we have nothing in between, no planet that bridges the gap between the rocky and the giant. And yet, when astronomers surveyed the planets around other stars, they found that this in-between size, larger than Earth but smaller than Neptune, is one of the most common kinds of planet in the entire galaxy. The universe is full of these worlds that our own solar system simply does not contain, which means we have no nearby example to study, no way to visit one or examine it up close. We are left to infer their nature from a distance, from the faint clues in their starlight, and those clues are often ambiguous, open to more than one interpretation. This is why a single world like K2-18b can be the subject of such vigorous scientific disagreement. Because we understand sub-Neptune so poorly, the same data can be read in different ways, supporting different pictures of what the planet is actually like. One team sees evidence of a vast ocean beneath a hydrogen sky. Another sees a more conventional, less hospitable world, and the available data are not yet decisive enough to settle the matter beyond dispute. This uncertainty is not a sign that the scientists are confused or careless. It is an honest reflection of how difficult it is to characterize a kind of planet we have never seen up close, using only the subtle imprint it leaves on starlight from over 100 light-years away. K2-18b is a member of the galaxy's most common but least understood class of planets, and its mysteries are, in a sense, the mysteries of that entire vast population of worlds. One possibility, the one that has generated so much excitement, is that K2-18b might be a particular and remarkable kind of world that some scientists have proposed, a type of planet for which they coined an evocative name, combining the words for hydrogen and ocean. The idea is that such a planet might be covered by a vast, deep, planet-wide ocean of liquid water beneath a thick atmosphere rich in hydrogen. Imagine that, a world larger than Earth, wrapped entirely in a single global ocean with no land at all, under a dense sky of hydrogen, the whole planet a water world beneath an alien atmosphere. If K2-18b is such a place, then it could, in principle, offer conditions where life might exist, in the warm depths of that world-spanning sea. Let yourself imagine standing, impossibly, on the surface of such a world, just for a moment, because the picture is both beautiful and deeply strange. There would be no land anywhere, no continents, no islands, no shore, only the endless ocean stretching in every direction to a horizon that curves around a world larger than Earth. Above you would arch a thick sky of hydrogen, the air far denser and heavier than anything on Earth, perhaps hazy, perhaps tinted in colors no human eye has seen. The light of the red dwarf star would fall across the waves in deep reddish hues, a ruddy, alien daylight utterly unlike the white gold light of our sun. The water might be warm, even hot, and the pressures in the depths immense. It would be a world of water and sky and nothing else, a single vast sea beneath an alien atmosphere, rolling on and on beneath a red and unfamiliar sun. And somewhere in those depths, if the most hopeful interpretation is right, there might be life drifting in the warm, dark water, exhaling its chemical breath into that strange sky. It is a vision that captures the imagination precisely because it is so different from Earth, and yet in its essentials, potentially hospitable to life. We tend to imagine alien worlds as either Earth-like twins or barren hellscapes, but a Hycean world is neither. It is a genuinely new kind of place, neither like our own world, nor obviously dead. A vast ocean planet that could, conceivably, harbor living things in conditions no earthly creature has ever known. The very idea expands our sense of where life might take hold, suggesting that habitable worlds need not look like Earth at all, that life might flourish in environments we had never seriously considered, under hydrogen skies, in planet-wide seas, around the dim red stars that fill the galaxy. Whether or not K2-18b itself turns out to be such a place, the possibility that worlds like this exist, and might be common, widens the search for life enormously. It was this possibility, the possibility that K2-18b might be an ocean world potentially suited to life, that made it such a tempting target for Webb, and that set the stage for what the telescope would find. It must be said, and we will return to this, that whether K2-18b is truly such an ocean world is itself far from certain. There are other possibilities for what kind of planet it might be, some of which would be far less friendly to life, and the debate over its true nature is ongoing and unresolved. But the tantalizing possibility that it might be a vast warm ocean under a hydrogen sky, a world where life could conceivably exist, is what drew the most powerful telescope ever built to study its air. And when Webb turned its great mirror toward that distant point of light, and caught the starlight filtering through the planet's atmosphere, and spread that light out to read the fingerprints of its gases, it found something that made the world sit up and take notice. The first things Webb found in the atmosphere of K2-18b were molecules built around carbon dioxide and methane, the same carbon dioxide we exhale and that fills our own skies, and the same methane found in natural gas and in the atmospheres of the giant planets. On their own, these molecules do not signal life. They are common throughout the cosmos and can be produced by ordinary, non-living processes. But their particular combination, and the absence of certain other molecules that scientists expected to find if the planet were a different kind of world, was taken by some researchers as consistent with the ocean world picture, with the idea that beneath that hydrogen sky there might indeed be a vast sea of liquid water. The carbon-bearing molecules in this reading helped paint a picture of a world that might just be the kind of place where life could exist. But they were not, in themselves, a sign of life. The sign of life, the thing that made the whole world catch its breath, was something else, something far rarer and far more provocative. Before we come to that, it is worth understanding why even the carbon-bearing molecules caused excitement, because it sets the stage. The particular combination Webb detected, and the things it did not detect, were read by some researchers as fitting the ocean world picture rather than the alternatives. On a planet that was simply a small, gas-rich version of Neptune, with no water surface, scientists would expect to see certain molecules in certain proportions, including significant amounts of ammonia. The apparent scarcity of ammonia, combined with the presence of the carbon-bearing molecules, was taken by the team that favored the ocean interpretation as a clue, a hint that the planet's chemistry might be shaped by a vast body of liquid water below, which could absorb the ammonia and alter the balance of gases in the air above. In this reading, the very pattern of what was present and what was absent pointed toward the hopeful picture of a water world. It was not proof, and others disputed the interpretation, but it was enough to make the ocean world idea seem plausible, and to set expectations for what might be found next. So the stage was set, a planet that might be a vast ocean, an atmosphere whose chemistry some read as consistent with that ocean, and a telescope capable of probing that atmosphere for the subtlest of signals. Against this backdrop, the search turned to the molecules that would matter most, the potential biosignatures, the gases that might betray the presence, not just of water, but of life. The carbon-bearing molecules had painted a picture of a world that might be habitable. The question now was whether the air of that world held any sign that it was actually inhabited. And it was in pursuing that question, in sifting through the faint signals at the very edge of detectability, that the researchers found the trace that would set the world talking, the tentative whisper of a molecule that, on Earth, means life. Buried in the data, faint and tentative, was a hint of another molecule, one with a far more startling significance. Its name is dimethyl sulfide, often shortened to DMs. It is a sulfur-bearing molecule, and on the face of it, it might sound as unremarkable as the others. But dimethyl sulfide is not unremarkable at all, because of where it comes from. Here on Earth, dimethyl sulfide is produced almost entirely by living things. The overwhelming majority of it comes from life in the oceans, from the vast multitudes of microscopic marine organisms, the phytoplankton, the tiny drifting life that fills the seas. When you stand at the coast and breathe in that distinctive smell of the sea, part of what you are smelling is dimethyl sulfide, the chemical breath of ocean life. On our planet, this molecule is, to a very strong degree, a product of biology, a chemical signature of living processes. To appreciate why this molecule carries such weight, consider where it comes from on Earth. The oceans of our world are filled with phytoplankton tiny photosynthesizing organisms that drift in the sunlit upper layers of the sea in numbers beyond counting, forming the base of the entire marine food web and producing a vast share of the oxygen we breathe. These organisms, as part of their life processes, release a chemical compound that breaks down in seawater and the air to produce dimethyl sulfide, which then rises into the atmosphere. The scale of this is enormous. The world's oceans pump out an immense quantity of this molecule continuously. The collective exhalation of countless invisible living things, it plays a role in the formation of clouds, in the cycling of sulfur through the environment, in the very chemistry of our atmosphere. It is, in a real sense, one of the chemical signatures of a living ocean, a molecule whose presence in our air is woven directly into the presence of life in our seas. This is precisely what makes it such a compelling candidate for a biosignature, a chemical marker that might reveal life on another world. The logic is straightforward and powerful. Find a molecule that, as far as we know, is produced overwhelmingly by life. Detect it in the atmosphere of another planet, and you may have found a sign that life exists there too. Dimethyl sulfide fits this description better than almost any other molecule we know of, because its connection to biology on Earth is so strong and so direct. If you were drawing up a list of the chemical signs that would most excite scientists if found in the air of a distant world, dimethyl sulfide would be near the very top. Precisely because here, in the one place we can check, it is so closely tied to the presence of living things. That is why its tentative appearance in the data from K2-18b set off such a wave of excitement, and why, even shrouded in caution, it represents one of the most provocative findings in the history of the search for life beyond Earth. This is why a hint of dimethyl sulfide in the atmosphere of a distant world is so electrifying and so unsettling. A molecule that, in the only example we know, is made almost entirely by life, detected in the air of a planet that might be a vast warm ocean, more than 100 light-years away. If that molecule is truly there, and if it is being produced the way it is produced on Earth, then it would mean that the ocean of K2-18b is filled with life, that the planet's seas are teeming with living organisms exhaling their chemical signature into the sky, just as Earth's oceans do. It would mean that we had detected, across the vast gulf of space, the chemical breath of an alien biosphere. This is what scientists call a potential biosignature, a chemical sign that could indicate the presence of life, and dimethyl sulfide is one of the most provocative biosignatures imaginable, precisely because of its strong association with living things. So there it was, a possible ocean world, in the habitable zone of its star, with an atmosphere that some read as consistent with a vast sea of liquid water, and within that atmosphere, a tentative trace of a molecule that on Earth is the chemical signature of ocean life. When the strengthened hint of this molecule was announced, it made headlines around the world, hailed in many places as the strongest sign yet of possible life beyond the Earth. For a moment, it seemed as though the ancient question, "Are we alone?" might finally be tilting toward an answer, and that the answer might be no. The reaction to the announcement captured something about how deeply this question lives in us. Across the world, the news spread rapidly, and people who had never heard of K2-18b found themselves contemplating the possibility of life on a distant world. There was a palpable excitement, a sense that something momentous might be happening, that the long human wandering might be approaching a turning point, and underneath the excitement ran that distinctive mixture of feelings the question always evokes, the wonder and the awe, but also a touch of something more unsettling, the vertigo of imagining that we might truly not be alone. For a brief while, the idea hung in the air everywhere, electric and strange. The thought that perhaps, just perhaps, the air of a far-off planet carried the breath of alien life, and that we had caught it, here, with our instruments, across the impossible gulf of space. That surge of excitement is worth understanding, because it reveals how ready we are, as a species, to receive this kind of news, how much we long for it, how powerfully the question grips us. But that very readiness, that hunger for an affirmative answer, is also exactly why caution is so essential, because when we want something to be true this badly, we are at our most vulnerable to believing it before the evidence warrants. The excitement that greeted the announcement was a beautiful expression of human curiosity and hope, but it also carried a risk, the risk of running ahead of the science, of treating a tentative hint as a confirmed discovery, of letting our longing outpace our knowledge. The responsible scientists understood this, and even amid the excitement, they worked to temper expectations, to remind everyone that a hint is not a finding, and that the path from this tantalizing signal to a genuine confirmation of life would be long, demanding, and far from certain. But science does not work by headlines, and the most important part of this story is the part that the headlines often rushed past: the powerful, necessary, and sobering reasons for caution. Here is where we must slow down and be rigorously honest, because the caution is not a footnote to this story. It is central to it, and understanding it is what separates real science from wishful thinking. The detection of dimethyl sulfide on K218b is tentative. That word, tentative, is doing enormous work, and it matters. In science, especially in a claim as enormous as a possible sign of alien life, there are strict standards for what counts as a real, confirmed detection, and the hint of dimethyl sulfide does not yet meet them. The signal in the data is faint, at the edge of what the telescope can reliably distinguish from random noise. It is the kind of signal that might be real, or might be a statistical fluke, a pattern that looks like something but could be nothing. Scientists have a high bar for certainty precisely because our instruments are imperfect, and our eagerness to find something can lead us astray, and by that bar, this detection is far from secure. And the doubts go deeper than just the strength of the signal. A number of scientists have raised serious questions about whether the molecule is there at all, reanalyzing the same data and finding that the evidence for dimethyl sulfide weakens or even vanishes under different methods of analysis. When a result is this faint and this important, independent researchers will pore over the data, test it in different ways, and sometimes reach different conclusions, and that healthy scientific scrutiny has left the detection contested rather than settled. Some teams see a hint of the molecule. Others, looking at the same numbers, are not convinced it is there. This is not a sign that science is broken. It is science working exactly as it should, demanding that an extraordinary claim be supported by extraordinary and reproducible evidence before it is accepted. It helps to understand the standards that scientists hold themselves to in cases like this, because those standards are what protect us from fooling ourselves. In physics and astronomy, there is a well-known scale for how confident one can be that a signal is real and not just a fluke of random noise, and the threshold for claiming a genuine discovery is set deliberately high, requiring a level of statistical confidence so strong that the odds of the signal being a chance fluctuation are extremely small. The tentative hints from K218b have generally fallen well short of that demanding threshold. They are at the level where a signal is interesting, worth reporting and investigating, but nowhere near the level where it could be called a confirmed detection. Scientists distinguish sharply between a hint and a discovery, and they reserve the language of discovery for results that have cleared the highest bar. By that standard, what we have for K218b is a hint, an intriguing possibility, not a confirmed finding, and honest scientists are careful to say so. This caution is especially important in the search for life, because the history of science is littered with premature claims that did not hold up, with signals that looked tantalizing and then dissolved under closer scrutiny. There have been past announcements of possible signs of life on other worlds and in other contexts that generated great excitement and then faded as the evidence was re-examined and alternative explanations emerged. Each of these episodes taught the scientific community to be more careful, more demanding, more skeptical of its own hopes. The search for life beyond Earth is a field where the desire to find something is so strong and the stakes so high that researchers must guard especially hard against wishful thinking, against seeing what they want to see in faint and ambiguous data. The caution surrounding K218b is not a failure of imagination or a lack of excitement. It is the hard-won wisdom of a field that has learned, again and again, how easy it is to be fooled, and how important it is to be sure. Then there is a deeper question still, one that would matter even if the molecule were definitely present. Is dimethyl sulfide really a reliable sign of life? On Earth, it is made overwhelmingly by living things, yes, but scientists have come to realize that it can also be produced, at least in some quantities, by processes that have nothing to do with life at all. It has been detected in environments where no life exists, and laboratory studies and observations have suggested non-biological pathways that could create it under the right conditions. So even if K218b's atmosphere does contain dimethyl sulfide, that would not by itself prove the presence of life, because there might be some ordinary chemical or geological process on that strange world, under that thick hydrogen sky, capable of producing the molecule without any living thing involved. A potential biosignature is only as good as our confidence that life is the only way to make it, and for dimethyl sulfide, that confidence is not absolute. And finally, there is the question of the planet itself, of whether K218b is even the kind of world that could harbor life at all. Remember that its true nature is debated. The hopeful picture is of a warm ocean under a hydrogen sky, but other scientists have argued that K218b might be a very different and far less hospitable kind of world. Perhaps a planet with no liquid water surface at all. Perhaps a world whose ocean, if it exists, is scaldingly hot or buried under crushing pressure. Or perhaps a planet that is more like a small, gas-shrouded version of Neptune, with no habitable surface anywhere. If K218b is not actually an ocean world suited to life, then the whole interpretation of the chemical signals shifts, and the case for biology weakens further. This debate over the planet's true nature is not a minor side issue. It is fundamental, and it remains genuinely unresolved among the scientists who study these worlds. Some researchers have argued forcefully that the data are better explained by K218b being a planet with a deep, dense atmosphere and no accessible liquid water surface at all, or even a world with a magma surface beneath its gases, conditions utterly hostile to life as we understand it. Others maintain the ocean world interpretation. The disagreement runs deep because sub-Neptunes are so poorly understood. With no example in our own solar system to study up close, we are forced to infer their nature from limited, hard-won data, and reasonable scientists looking at the same evidence can come to different conclusions about what these worlds are actually like. K218b sits at the center of this uncertainty, its very character contested, and until that character is settled, any claim about life there rests on shaky ground. All of this caution, taken together, paints a sobering but honest picture. We have a faint signal, at the edge of detectability, whose very presence is disputed by independent analyses. We have a molecule that, even if present, might be produced without life. And we have a planet whose basic nature, whether it is even the kind of place where life could exist, remains a matter of active debate. Any one of these uncertainties would be enough to demand caution. Together, they make it clear that we are very far from having found life on K2-18b. This is not to dismiss the discovery, which is genuinely important and genuinely exciting, but to place it in its true context as a tantalizing hint at the frontier of an enormously difficult search, a hint that may or may not survive further scrutiny, rather than as the answer to the ancient question. The honest scientist holds it as a possibility worth pursuing, not a conclusion to be celebrated, and that restraint is exactly what the moment calls for. So the caution stacks up at every level. The signal is faint. Its very presence is contested. The molecule may not require life, even if it is there, and the planet may not be habitable in the first place. Every one of these doubts is real, and any one of them could mean that there is no life on K2-18b at all. So why, given all these doubts, does this story matter so much? Why did it make headlines around the world? And why are we spending this time on a tentative, contested, unconfirmed hint that may well turn out to be nothing? Because even as a possibility, even held at arm's length, with every appropriate caution, it touches something profound, and it marks a genuine turning point. For the first time, the question of whether we are alone has become something we can actually investigate, with real instruments, on real worlds, producing real data that we can argue about. We have moved from pure wondering to actual searching. And in that searching, we have found for the first time a result tantalizing enough that serious scientists felt compelled to announce it and debate it. Whether or not this particular hint holds up, the fact that we can now have this conversation at all, grounded in actual observations of an actual planet's atmosphere, is itself a milestone in the history of our species. Think about the long arc that leads to this moment. For thousands of years, the question of life beyond Earth lived entirely in the realm of myth, philosophy, and imagination, with no way to touch it. Then, gradually, it became a subject of scientific speculation, something thoughtful people could reason about, even without evidence. Then we discovered that other planets existed at all, turning the question from pure abstraction into something with real objects attached. Then we learned to detect those planets, then to measure their sizes and orbits, then, astonishingly, to begin reading their atmospheres. And now, at last, we have reached the point where we can detect, in the air of a distant world, the faint possible trace of a molecule associated with life. Each of these steps was once thought impossible or unimaginable, and each was achieved, one after another, by patient human ingenuity. The hint from K2-18b, whatever it turns out to mean, sits at the end of this long chain of advances, a marker of just how far we have come in our ability to investigate the once untouchable question of cosmic life. And this progress shows no sign of stopping. Each generation of instruments reveals what the previous generation could not, and each discovery opens questions that drive the building of the next. We are riding a wave of accelerating capability, our power to probe distant worlds growing year by year, our reach extending steadily outward. The tentative signal from K2-18b is not the culmination of this effort, but a waypoint along it, a sign of how much we can already do, and a promise of how much more we will be able to do soon. To stand at this point in the arc, able to detect what we can now detect, on the threshold of detecting so much more, is to stand at one of the most exciting moments in the entire history of the human attempt to understand our place in the universe. The conversation we are having tonight would have been impossible just a few years ago. The conversations we will be able to have a few years from now may be more extraordinary still. And consider what it would mean if a finding like this, on this world or some other, were one day confirmed. Imagine that the molecule were definitely there, and that all the alternative explanations were ruled out, and that we could say with confidence that the air of a distant world carried the chemical signature of life. It would not be intelligent life, not creatures or civilizations, just the chemical breath of simple living organisms, perhaps microscopic life in a distant sea, and yet it would be one of the most momentous discoveries in all of human history. It would mean that life is not unique to Earth, that it arose at least twice, independently, on two different worlds, and that if it arose twice, it very likely arose countless times. That the universe is not the lifeless desert it might be, but a place where life takes hold wherever it can. In a single stroke, it would transform our understanding of our place in the cosmos, ending the long isolation of being the only living world we know. There is something almost overwhelming in contemplating that, a possibility so large that the mind struggles to hold it. For the entire span of human existence, every living thing we have ever known, every plant and animal and microbe, every person who has ever lived has belonged to a single biosphere, a single web of life on a single world, the only life in a silent universe. To learn that there is another, that somewhere out in the dark there is a second living world, would be to discover that we are part of something far larger than we ever knew, that life is a phenomenon of the cosmos, and not just of the Earth. It would be a discovery that reaches into the deepest part of how we understand ourselves, our world, and our place in the vastness of everything. And here is a subtle point that makes the implication even larger. If life were found to have arisen independently on even one other world, it would tell us something not just about that world, but about the universe as a whole, about the very nature of life. It would suggest that life is not a freak accident, not a one-in-a-universe fluke, but something that the cosmos produces readily, given the right conditions, a natural outcome of physics and chemistry, rather than an impossible miracle. Because if life arose twice, on two separate worlds, with no connection between them, then the most reasonable conclusion would be that it arises easily, that wherever the conditions allow, life tends to appear, and that would mean the universe is not a vast dead expanse with a single living anomaly, but a place fundamentally hospitable to life, a cosmos in which life is woven into the order of things, emerging again and again across the countless worlds. A single confirmed example elsewhere would transform our entire picture of how common life is in the universe, from a sample of one, which tells us almost nothing, to a sample of two, which tells us a great deal. This is why even the simplest life, even microscopic organisms in a distant sea, would be such a momentous find. We sometimes imagine that the great discovery would be intelligent life, civilizations, beings we could communicate with. And of course, that would be extraordinary. But in truth, even the discovery of the humblest life, a distant ocean filled with nothing more than simple drifting organisms, would be one of the most important findings in the history of human thought, because of what it would imply about the prevalence of life everywhere. The question is not really whether there are others to talk to. It is whether life itself is rare or common, lonely or abundant, a singular accident or a cosmic commonplace. And the chemical breath of even the simplest organisms, detected in the air of even one other world, would answer that question in the most profound way, telling us that we are part of a living universe rather than a dead one. And it is precisely because the stakes are so high that the caution matters so much, and that the scientists urging restraint are doing exactly the right thing. A discovery this momentous must not be claimed until it is certain, because the cost of crying out that we have found life, only to be proven wrong, would be enormous, both for science and for the public trust. So the careful scientists hold back, demand more data, test and retest, refuse to celebrate until the evidence is overwhelming. This is not timidity, it is the proper gravity that a question this large deserves. And it means that, for now, we are left in a state of suspended wonder, holding a possibility we cannot yet confirm or rule out, staring at a distant point of light and not knowing, truly not knowing, whether something there is alive. This state of not knowing is, in its own way, one of the most honest and most human places to stand. And there is a strange richness in learning to dwell in it without rushing to resolve it. We are creatures who crave answers, who want the question of cosmic life settled one way or the other, who find the suspense almost unbearable. But the universe does not deliver its secrets on our schedule, and the search for life is a slow and patient enterprise, measured in years of careful observation and cautious analysis. To engage with it honestly is to learn to hold an open question, to live alongside a profound uncertainty, to feel the pull of both the hopeful and the skeptical answers without collapsing prematurely into either. There is a discipline in that, and also a kind of beauty. The beauty of staying genuinely open, of letting the mystery remain a mystery until the evidence is truly in. And perhaps that is the right spirit in which to carry this whole story, not as a settled fact to be filed away, but as a living question to be held with curiosity and care. The hint from K218b is not an answer. It is an invitation to wonder, to pay attention, to follow along as the search unfolds in the years to come. It places us in the middle of an unfinished story, one of the great unfinished stories of our time, and asks us to be patient, to be honest, to be open to whatever the universe eventually reveals. Whether the answer, when it comes, is that we are alone or that we are not, the asking itself, the careful, patient, honest search, is one of the noblest things our species does. And to be alive while it is happening, to witness even a single tantalizing chapter of it, is a genuine privilege. There is a particular kind of vertigo that comes with this not knowing, and it is worth sitting with, because it is one of the strangest feelings our era has made possible. Go outside on a clear night, find the direction of the constellation Leo, and know that somewhere in that patch of sky, far too faint to see, there is a star, and around that star there is a world, and in the air of that world there may, or may not, be the chemical trace of life. You are looking with your own eyes in the direction of a place that might be inhabited. Not inhabited by anything you could speak to, not a civilization, but perhaps a living ocean, a world whose seas might be filled with simple life, exhaling its chemical breath into an alien sky. And you cannot know. You can only look and wonder and feel the strange weight of a question that for the first time in history has a real and specific place attached to it, an actual point of light you can turn toward. This is something genuinely new in human experience, For all the millennia that people wondered whether we are alone, they wondered in the abstract, gazing at the whole sky, at the general vastness. But now the wondering has a target. There is a specific world with a name, at a known distance, in a known direction, that might harbor life. The question has come down out of the realm of pure philosophy and attached itself to a real place in the real sky. There is an intimacy to this that the old abstract wondering never had. When the question was vague, spread across the whole anonymous sky, it could remain comfortably distant, a matter for idle musing. But now it has a location, a specific point you can turn toward, a specific world you can name. To know that there is a particular planet, in a particular direction, at a particular distance, that might at this very moment be carrying life in its seas, is to feel the question become personal, almost like knowing that a light is on in a distant house, and wondering who, if anyone, is home. The cosmos is no longer an undifferentiated vastness. It has become a place with addresses, with specific worlds we can point to and ask about, and that specificity transforms the ancient wondering into something far more immediate and far more haunting. And whether or not K218b turns out to be inhabited, that change is profound. We now live in an era where the question of alien life is not just a dream, but an investigation with actual addresses, actual worlds we can point to and study and argue about, actual targets for our most powerful instruments. The ancient question has become a research program, and that is a transformation in the human relationship with the cosmos. And there is, woven through the wonder, a thread of something that feels like dread, or perhaps awe so large it shades into fear. To contemplate that we might not be alone is to feel the universe shift beneath you, to sense the vastness becoming, somehow, more occupied, more alive, stranger. The silence of the cosmos has been, in its way, a kind of comfort, a familiar loneliness. We have always been the only living world we knew, secure in our uniqueness even as we longed for company. To imagine that the dark is populated, that life is out there, perhaps everywhere, is to feel that familiar picture dissolve, replaced by something far less certain and far more vast. It is the eerie feeling of realizing that the universe might be watching back, or at least living back, that the emptiness might not be empty, that we might be one small living world among countless others scattered through the dark. There is a strange doubling in this feeling, a sense in which the possibility of life out there is both deeply comforting and deeply unsettling at the same time. Comforting, because the thought of being utterly alone in an infinite dead universe is a lonely one, and the idea that life might be out there, that we might have company in the cosmos, answers a longing as old as humanity, the wish not to be the only ones. But unsettling too, because there is a kind of safety in the familiar loneliness, a simplicity in a universe that is ours alone, and to imagine it populated, to imagine living things stirring in distant seas under alien skies, is to feel the ground of our certainty shift, to confront a cosmos far stranger and more crowded and less knowable than the empty one we had grown used to. The same possibility that thrills us also disquiets us, and both responses are honest. Both are part of standing at this threshold and peering through. And there is something almost dizzying in the specificity of it now, in the way the abstract has become concrete. It is one thing to wonder, vaguely, whether life exists somewhere in the vast universe. It is another to look toward a particular faint star, to know the name and the distance and the direction of a particular world, and to wonder whether that specific place, that one world among the billions, might at this very moment harbor living things. The vagueness that made the old question bearable is gone, replaced by a pointed, particular, almost intimate uncertainty. There is a world out there with a name, and we do not know if it is alive, and we are looking right at it. That is a new kind of relationship to have with the cosmos, a new kind of question to carry, and it brings the ancient wondering down from the heavens and plants it firmly in a specific patch of the real night sky. That feeling, that mixture of wonder and unease, is the proper response to standing at this threshold, this moment when the question of cosmic life has become real, but not yet answered. We are poised between two pictures of the universe, the lonely one and the living one, and we do not yet know which is true. K2-18b, with its tentative hint and its mountain of caveats, is a single uncertain glimpse through that doorway, not enough to tell us which world we live in, but enough to make us feel, perhaps for the first time, that the door is really there, and that we are actually standing at it, looking through, into a cosmos that may be far more alive than we ever allowed ourselves to believe. It is worth noticing how this discovery, even in its uncertainty, changes the texture of looking up at the night sky. Once, the stars were simply beautiful and remote, points of light with no particular connection to the question of life, a decorative backdrop to the night. But now, knowing what we know, knowing that worlds surround nearly every one of those stars, and that some of those worlds might harbor life, and that we have begun to detect possible traces of it, the night sky becomes something different. A field of possibilities, a vast array of potential homes for the living. Each point of light becomes a sun with its own worlds, and each of those worlds becomes a place where life might, or might not, have taken hold. The sky is no longer a flat ceiling of distant lights, but a deep ocean of possibility, and to look up at it is to look out across countless potential biospheres, most of them forever beyond our reach, any one of which might be alive. This transformation of the night sky, from decoration to possibility, is one of the quieter gifts of the search for life, and it is available to anyone, regardless of whether K2-18b or any particular world turns out to be inhabited. You can step outside on a clear night, look up at the scattered stars, and know that you are looking at a sky full of worlds, a sky in which life might be far more common than we ever imagined, a sky whose silence might conceal a multitude of living things. That knowledge alone, the simple awareness of how full of worlds and possibilities the sky truly is, enriches every glance upward, lending the familiar stars a new depth and a new mystery. We have not yet found life out there, but we have learned that the sky is the kind of place where life might be, and that alone has changed forever what it means to look up. It is important to understand that K2-18b is not the end of this story, but very nearly the beginning, the opening move in what will be one of the great scientific quests of this century. Whether or not this particular hint holds up, the search it represents is only just getting underway, and the tools for it are growing more powerful every year. Webb itself will continue to study K2-18b, gathering more data, looking again and again, working to either strengthen the signal until it becomes undeniable, or to show that it fades away into noise. More observations are the only way to resolve the question, and they are coming. In the next few years, we may know much more about whether that distant atmosphere truly holds the chemical trace it seemed to, and whether that trace truly means what it might. And beyond K2-18b lie countless other worlds, an entire galaxy full of planets waiting to be examined. Webb is already turning its eye toward other potentially habitable planets, reading their atmospheres, searching for the telltale fingerprints of gases that might indicate life. And Webb is only the current frontier. Even more powerful telescopes are being planned and built. instruments specifically designed to hunt for signs of life on distant worlds, to analyze the atmospheres of many planets, to search for biosignatures across the galaxy with ever greater sensitivity and rigor. We are at the dawn of an age in which the search for life beyond Earth has become a real, systematic, technological enterprise, no longer a matter of pure speculation, but of careful observation, world by world, atmosphere by atmosphere. Consider what is coming in the years and decades ahead, because it transforms a single tantalizing hint into the opening chapter of a vast undertaking. Astronomers are designing and building telescopes specifically intended to find and study potentially habitable worlds, instruments even larger and more capable than Webb, both on the ground and in space, some of them conceived from the start with the search for life as a central goal. Future observatories may be able to block out the overwhelming light of a star directly, allowing them to see the faint planets beside it and study their atmospheres in detail, rather than relying only on the brief moments of a transit. They may be able to examine not just one or two promising worlds, but dozens or hundreds, building up a real census of the atmospheres of distant planets, searching systematically for the chemical signs of life across many worlds at once. The search that K218b represents is just beginning, and the tools to carry it forward are growing more powerful with each passing year. And this means that the question we have wondered about for all of human history may actually be answered, not in some unimaginable far future, but perhaps within the lifetimes of people alive today. It is genuinely possible that within the coming decades, through the patient examination of world after world, we will gather evidence strong enough and clear enough to say, with confidence, that life exists, or has existed, somewhere beyond the Earth. Or we may search and find nothing, and that absence, too, would tell us something profound, that life may be rarer and more precious than we hoped. Either way, we stand at the beginning of a process that could, for the first time, deliver a real answer to the ancient question, and that is an extraordinary thing to be alive for. A moment when one of humanity's oldest mysteries has finally become a question that science can actually pursue toward resolution. This means that we, the people alive right now, occupy an extraordinary moment in the long history of our species. We are the first generation that has ever been able to actually search for life beyond the Earth, to move the ancient question from the realm of wondering into the realm of investigation. Every human being who came before us could only look up and imagine. We can look up and measure. We can point our instruments at specific worlds and read their air and ask, with real data, whether they might be alive. That is a power no previous generation possessed, a threshold our species has only just crossed, and it places us at a unique vantage point in the unfolding story of human understanding. The answer to whether we are alone may not come in our lifetimes, or it may come tomorrow, but either way, we are the ones who have begun, in earnest, to look. And there is something deeply moving in that, in the image of a species that, after countless generations of wondering, has finally built the tools to ask the universe directly whether it is alone, and has begun, patiently and carefully, to listen for an answer. It is worth dwelling for a moment on the strange power of even a negative result, because it reveals how meaningful this search is, no matter what it finds. Suppose we search world after world, examining the atmospheres of hundreds of potentially habitable planets, and find no sign of life anywhere, no biosignatures, no chemical traces, nothing but the ordinary gases of dead worlds. That would be a disappointment to many, but it would not be a failure. It would be a profound discovery in its own right. It would tell us that life is genuinely rare, that the conditions for it, or the spark that ignites it are far harder to come by than the abundance of habitable worlds might suggest. And that in turn would make the life on Earth and our own existence more precious and more astonishing than ever. A rare flame in a vast darkness, something that emerged against tremendous odds. Even silence, if we search thoroughly enough, speaks volumes about our place in the cosmos. And if instead we find signs of life, even on a single other world, the meaning runs in the opposite direction, but is equally profound, telling us that life is woven into the fabric of the universe, that we are part of a living cosmos rather than a dead one. The beauty of this search is that there is no outcome without meaning. Whatever we find or fail to find will teach us something deep about the nature of reality and our position within it. This is why the search is worth undertaking, regardless of where it leads, why scientists pour their careers into it, why it matters that we have begun. We are asking a question whose every possible answer is profound, and simply by asking it well, by searching honestly and carefully, we are learning something about the universe and about ourselves that no previous generation could have known. Whatever K218b turns out to be, whether its tentative hint blossoms into confirmation or fades into nothing, the search will go on, world by world, year by year, telescope by telescope, until perhaps one day, on some planet, the evidence becomes overwhelming, and we learn at last that we are not alone, or until we have searched so long and so widely that the silence itself begins to speak. We have begun the search. And that, regardless of where it leads, is one of the most remarkable things our species has ever done. What does all of this mean for you, lying here, a single living being on a single living world, contemplating the possibility of life among the stars? It means, perhaps, a subtle but profound shift in how you see your own existence and your own world. Whether or not K218b is alive, the very fact that we are now seriously searching, that we have found even a tentative hint, invites you to feel your connection to the largest questions there are, to sense yourself not just as a person on Earth, but as part of the phenomenon of life in the universe. One instance of the living, on one world, wondering about the others. It is a way of belonging to something vast, of feeling that your own aliveness is part of a question that spans the entire cosmos, and it casts your own world, this Earth, in a new and precious light. For if life is rare, if K218b and all the other worlds turn out to be barren, then the Earth is a treasure almost beyond comprehension, a single living jewel in a vast dead cosmos, and every living thing upon it, including you, is part of something unspeakably rare and precious. And if life is common, if the universe turns out to be full of living worlds, then the Earth is part of a great cosmic community of life, one of countless places where the universe has stirred into living awareness, and you are a member of something vast and shared. Either way, the search for life beyond Earth deepens the meaning of life on Earth, throwing into relief the sheer wonder of being alive at all, on a world that is, at the very least, one of the places in the universe where life has taken hold. It is a curious and beautiful thing that looking outward, toward distant worlds, should make us look more closely and more gratefully at our own. The search for life elsewhere inevitably turns our attention back to the extraordinary fact of life here, to the living world beneath our feet that we so often take for granted. Every blade of grass, every bird, every person, every microbe in the soil and the sea is part of the one example of life we know for certain, the one biosphere whose existence is beyond doubt. We go looking for the faint chemical breath of life across 100 light years, and in doing so, we are reminded of the riot of life all around us, the astonishing abundance and variety of living things on this single small planet, a richness we rarely pause to marvel at. The distant search lends a new wonder to the near reality, helping us see our own living world, for a moment, as the rare and precious thing it is. And there is a kind of kinship in it too, a sense of solidarity with whatever life might be out there. If the oceans of K2-18b, or of some other distant world, are indeed filled with simple living things, then those organisms, however alien, however different from anything on Earth, would be our fellow travelers in the strange phenomenon of being alive, fellow instances of matter that has stirred into life, fellow participants in the rarest and most remarkable thing the universe does. We would not be able to speak to them, would never meet them, would know them only as a chemical trace in distant starlight. And yet there would be a bond, the bond of shared aliveness, the recognition that we are not the only ones, that life has happened more than once, that across the vast dark there are other living worlds keeping their own quiet vigil of existence. That sense of kinship with unknown life across impossible distances is one of the gentler and more beautiful feelings this whole search can evoke. There is something humbling and something elevating in holding both your smallness and your significance at once. You are a tiny, brief thing, one living being among billions on a small planet circling an ordinary star in an ordinary galaxy in an unimaginably vast universe. And yet you are also a living thing, a part of that rarest and most remarkable phenomenon, life. The universe somehow stirred into awareness of itself, and you are alive at the very moment when your species has begun to search for others like itself among the stars. To be small and significant at once, to be a brief living spark, contemplating the possibility of other sparks across the dark, is a strange and beautiful condition, and the story of K2-18b, whatever its outcome, invites you into it. There is an old human tendency, when confronted with the vastness of the universe, to feel diminished, to feel that our smallness somehow makes us insignificant, that against the scale of the cosmos our lives and concerns shrink to nothing. But the search for life among the stars suggests a different and more hopeful response. Yes, we are small, almost unimaginably small against the scale of the galaxy and the universe beyond. But we are also rare and aware and alive, and we are the kind of beings who can look out across that vastness and ask whether anyone else is there. The capacity to wonder about cosmic life, to build telescopes and read the atmospheres of distant worlds, to hold the great question in our minds, is itself something precious and remarkable, perhaps as remarkable as anything in the cosmos. Our smallness does not cancel our significance. The two coexist, and the contemplation of the vast universe, far from diminishing us, can deepen our appreciation of the strange privilege of being conscious and alive within it. And whatever the search eventually reveals, it places our own lives in a grander context, connecting our brief existence to the largest questions and the deepest mysteries. When you hold the question of cosmic life in your mind, you are participating, in a small way, in one of the great endeavors of your species, sharing in the wonder that drives the scientists at their telescopes, joining the long line of humans who have looked up and wondered. Your own moment of contemplation, lying here tonight, is part of the same human impulse that built the great observatory, now reading the light of distant worlds. There is a kind of communion in that, a sense of being part of something larger than yourself, connected through this shared wondering to all the others, past and present, who have gazed at the stars and asked whether we are alone. The question belongs to all of us, and in holding it, you take your place in a story that spans the whole of human history. And it is worth holding, too, the simple fact that none of this uncertainty needs to trouble your peace, because the search for life among the stars, profound as it is, asks nothing urgent of you. The distant world will go on orbiting its star, whether or not we ever resolve the question of its air. The scientists will go on gathering their data, patiently, carefully, over years, and you can simply hold the wonder of it, the vast open question of whether we are alone, as one of the great and beautiful mysteries of being alive at this moment in history, a mystery you are privileged to witness unfolding, but not one you must resolve or carry. It is enough to know that the search has begun, that the question is real, and that we are, at last, beginning to look. And perhaps there is a quiet comfort, too, in the very distance that separates us from K2-18b and all the other worlds we wonder about. Whatever is or is not happening in that far-off atmosphere, it is more than 100 light-years away, utterly remote from your life, your home, your rest tonight. The possibility of life out there changes nothing about the safety and reality of your own world. It adds only wonder, not threat. The distant ocean, if it is an ocean, rolls on beneath its alien sky regardless of anything you do or think, and whatever lives there, if anything does, is separated from you by a gulf so vast that it can never reach you, never trouble you, never be anything to you but a source of awe. The search for life among the stars is a search conducted at a safe and contemplative distance, a matter of wonder rather than worry, and you can engage with it purely as a marvel, holding the great question lightly, untroubled by it, free simply to be amazed. So you can let the wonder of it be exactly that, a wonder, a source of awe and curiosity and quiet amazement, with nothing demanded and nothing threatened. The distant world will keep it secret or yield it in time, and either way, your life here continues, warm and real and immediate, enriched rather than disturbed by the knowledge that the universe may be far more alive than we once believed. This is the gift the search offers to anyone who contemplates it. Not anxiety, but enlargement, a widening of the imagination, a deepening of wonder, a sense of participating, even just by paying attention, in one of the most profound quests our species has ever undertaken. And you can carry that gift gently with you, a small glowing ember of awe, as the day winds down and the great question settles into the quiet of the coming night. It is fitting that thoughts like these come most powerfully in the quiet of the night, when the day's concerns fall away and you can feel, more directly, the vastness of the sky above you and the depth of the questions it holds. In the busyness of daylight, the possibility of life on a distant world is an abstraction, a headline, easily set aside. But at night, in the stillness, looking up or simply lying in the dark, it becomes possible to feel the real weight of it, the genuine strangeness and wonder of knowing that somewhere out there, around a faint star in a familiar constellation, there is a world whose air may carry the chemical trace of life, and that we here have begun to search. The night is when the great questions breathe, when the mind can hold the vastness and the wonder, and find in them not fear, but a profound and quiet awe. And there is something especially fitting about contemplating distant worlds as you prepare for sleep, because sleep itself is a kind of letting go, a release of the day's grip on certainty and control, a willingness to drift into the unknown of the night. The question of life among the stars asks something similar of us, a willingness to release our need for immediate answers, to let a great mystery remain open, to drift alongside it without anxiety. You do not have to solve the cosmos before you rest. You do not have to know tonight whether that distant ocean holds life. You can let the question be vast and open and unresolved, the way the night sky is vast and open above you, and find in that openness not a source of unease, but a kind of spaciousness, a room for wonder, a gentle reminder that the universe is larger and stranger and more full of possibility than the small concerns of any single day. So let the distant world drift at the edge of your thoughts now, like a half-remembered dream, neither demanding your attention nor slipping entirely away. More than 100 light years off, it turns in the red light of its star, keeping whatever secret it keeps, indifferent to whether we ever learn it. And you are here, on this world, warm and safe and alive, one living being among all the life of this living planet, gazing out at the possibility of life elsewhere, and feeling, perhaps, a quiet kinship with whatever might be out there in the dark. There is peace in that, in the simple act of wondering gently about the cosmos as you settle toward rest, in feeling yourself a small and living part of a universe so vast that it may hold uncounted other living worlds, each turning quietly in the light of its own distant star. So as the night deepens around you, let the wonder settle gently, without any need to resolve it. Somewhere, more than 100 light years away, the planet K2-18b is orbiting its small red star, wrapped in its alien atmosphere, perhaps an ocean world beneath a hydrogen sky, perhaps something else entirely, holding its secret close. The light that will tell us more is already on its way, or waiting to be gathered, and in time we may know more. But for tonight, the question remains open, suspended, beautiful, one of the great mysteries of our moment in history, and you can simply rest in it, in the wonder of a universe that may be far more alive than we ever knew, without needing to know the answer. Letting the open question be a source of awe rather than anxiety as you drift toward sleep. Let the vastness hold you gently, as it always has. The same sky that holds K2-18b holds you, the same universe, the same physics, the same long unfolding story of matter and energy and, here and there, perhaps, life. You are part of it, a living being on a living world, gazing out at the possibility of other living worlds, and there is nothing in that to fear, only a deep and expansive wonder at the sheer scale and richness and mystery of the cosmos you belong to. Whether we are alone or not, the universe is a place of staggering wonder, and you are alive within it, at the very moment when we have begun to ask in earnest whether anyone else is too. There is a profound peace available in that, the peace of holding a great open question lightly, of letting the mystery of cosmic life be a source of wonder rather than worry. You do not have to know tonight whether K2-18b is alive. You do not have to resolve the deepest question our species has ever asked. You can simply let it be open, beautiful, unresolved, a mystery you are privileged to live alongside, and turn your attention back to the warm and immediate reality of your own life, your own breath, your own aliveness, here on this living world beneath the vast and possibly living sky. The search will go on. The distant world will keep its secret a while longer. And you can rest, tonight, in the wonder of being a living thing, in a universe that may be full of life, held gently by the same cosmos you have spent this night contemplating, safe and small and alive beneath the quiet stars. So let your thoughts slow now, and let the great question settle into the quiet of the night. You have traveled, tonight, across more than 100 light years of empty space, to a faint star in the constellation Leo, and to the strange and distant world that orbits it, a world whose air the most powerful telescope ever built may have read, and in which it may have found the faintest, most tentative, most debated hint of the chemical breath of life. You have seen how such a thing is even possible, the reading of a distant atmosphere through the light that filters through it. You have seen what was found, and you have weighed honestly all the reasons for caution. And you have felt the weight of the question it touches, the oldest question we have ever asked, and now you can let it rest. Picture it one last time, softly, without fear. A small red star glowing in the dark, more than 100 light years away. A world swinging around it, wrapped in an alien sky. Perhaps a vast warm ocean beneath, perhaps filled with simple life, perhaps barren and empty, we do not yet know. And a telescope, far from Earth, patiently gathering the faint light that grazed through that distant air, searching for the signatures of the gases within it, listening, in its way, for the chemical whisper of life across the void. It is one of the most profound things our species has ever attempted, and you have held it tonight, and felt its wonder, and seen both its hope and its honest uncertainty. There is nothing you need to do with this knowledge tonight. The scientists will go on gathering their data, testing the signal, debating its meaning, working patiently toward an answer that may take years to arrive. The distant world will go on orbiting its star, keeping it secret, indifferent to our wondering. And you can simply let it all be, the open question, the distant world, the great search just beginning, and turn toward rest, a living being on a living world, carrying now a little of the wonder of having looked, tonight, toward a place that might be alive. Let the distant star keep its quiet mystery. Let the question of whether we are alone remain open and beautiful and unresolved, a wonder rather than a weight, and let yourself rest in the simple, profound fact of your own aliveness, here now on this living world beneath the vast and ancient sky. You are here, alive and whole and safe, one living spark in a cosmos that may hold countless others, free to marvel at the great search our species has begun, and then to close your eyes and rest. The telescope will keep watching, the distant world will keep turning, and the question of whether we are alone will wait, patient and open, beneath the quiet stars as you drift toward sleep, a living being at peace in a universe that may after all be full of life, now and through the whole of this quiet night, exactly as it has been, all along, and will be, long after this quiet night has passed into morning.